All right, good morning. I am just going to touch base on a few things. I know I've talked to a few people and they wanted me to do a video over our overview that we had in class. So I am going to touch base on it, and then I've had a few questions, so I'm going to answer some of those on here as well. All right, so if you had questions about the overview, now is the time to listen, okay? All right, so this first page, it just shows you the concept of a function, okay? And we talked about three types of functions. So we talked about a linear function, which makes a line. It has a constant change, constant slope. We talked about a quadratic, which is what you see right here, okay? So you see an upside down U, okay? So this would be a negative quadratic function. If it was pointing up, that would be a positive quadratic function. And we call this U a parabola. The quadratic function is y equals x squared, okay? And then the next one we're going to talk about is exponential functions, okay? So I look at that like a Nike sign. So I am going to go over to page 2. All right, and I'm going to hit this play button, okay? So this right here is just going to show you each type of function. All right, so here we have a linear function. We all know what linear functions look like. Okay, so we're on number 4. So if you don't already have this and you want to write a few things down, know that it is constant, change. It has a pattern of constant addition. Okay, so it adds the same thing every time. All right, next we have an exponential function. Okay, so you kind of see the Nike sign. So instead of a constant addition, we have a constant multiplication. Okay, so I want you to write constant multiplication. Okay, so every time it is going by a half. So if I say 0.0625 divided by 0.125, I'm going to get 0.5, okay? Or I can say 0.125 times 0.5 and get 0.0625. So either way, it works. All right, last is, let me back up. Last is our quadratic function. This is a positive quadratic function. You'll see that it is y equals x squared. Okay. Now, if you look on the y side, the difference in those numbers are not the same. Okay. But when I click number 4, you noticed that the second column of numbers is the same. So what you need to know is the first set of numbers is the first difference. Okay? Second set is the second difference. So if the second difference in y is constant, then that's a quadratic function, okay? All right, right here you were just looking at number of units. So you see there's 3 sides on this triangle, okay? Next, it adds a triangle. So now we have 4 sides. If you look next, it says, what is the perimeter of the third figure? It's not 4 sides, but it is 5 because there are 2 bottoms. And the next one, if you see a pattern, you know it has to be 6. It's going up by 1 every time. All right, now this is where it gets a little tricky. So still right here, we still have 3 sides. Okay, first figure. Now let me back up. All right, I just added 3 little triangles, right? Okay, so if you're looking, I want you to count the points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, okay? So we have 12 points. All right, and if you look up, let's see, where is it at? In the gray part, it says consider a different process for generating a set of figures. Start with the same equilateral triangle as before. To make the second figure in the set, divide each triangle into thirds. Very important to know, okay? So I'm taking each triangle and going by thirds. So just this one time, we broke it into thirds, okay? So I am going to hit play. So on top is going to be our number of points, okay? So we have 12 points. And I just said we divide it by thirds. So our denominator has to be 3 because that's what it tells us. Just divide it into thirds every time. So we're going to type in 12 divided by 3, which is 4. Okay. Next, it just added more triangles. Okay. So think back. We had 3 points first. And then we had 12 points first. So how did I get from 3 to 12? What can I say? 3 times what is 12? 3 times 4 is 12. So I'm going to say 12 times 4 is 48. Okay? Now, remember, it is broken down into a third every time. So over here, the first time, it was broken into a third. The second time, it's broken into another third. So now I have a third times a third, which is a ninth. So remember, point on the top and how many thirds on the bottom. It is broken down into third again. Let me hit play. All right, so I had 48 points, okay? And it's going to be a denominator of 9. So we have 48 over 9, or if you simplified that, it would be 16 thirds, okay? Now, the last time you know we have to multiply by 4 to get our number of points. So 48 times 4 is 192. Okay, so now my thirds. I have a third, I have a third, and I have a third. So 1 times 1 times 1 is just 1 on top. But on the bottom, I have 3 times 3 times 3, which is 27. So it's not going to let me type that in, so we're going to have to simplify. So here I have a 3. Then I have a 12 over 3. Then I had a 48 over 9. And then I had 192 over 27. Okay, so just look at the top. Every time on the top, I multiplied by 4. Every time on the bottom, I multiplied by 3. Okay, so my common ratio is 4 over 3. And since I multiplied every time, then this would be a geometric sequence. Okay. All right, so I want to flip over to number 9 on your workbook page. Oh, it's a reinforced. Let me go to this side. All right, so we want to be right here. All right, so this is what you need to write if you do not have this written down. An arithmetic sequence goes up constantly by the same number, okay? It goes with a linear function, and it uses a common difference. Okay, example is 2, 4, 6, 8, 10. It goes up by 2, so my common difference is 2. All right. Next, geometric. Instead of being added the same thing every time, we're going to multiply by the same number. It goes with an exponential function, and it has a common ratio. And remember, a fancy word for fraction is ratio. 5, 10, 20, 40, so on. Okay, so each time I'm multiplying by 2. So my common ratio here is 2. Okay? All right, I had a few people ask me about a recursive definition. So I'm just going to talk through this real quick. A recursive definition is just the term that is before it, okay? So remember I said anytime you see n minus 1, You were just looking for that term before it, okay? So let's just use this example so I can show you. So we have f of 1 equals 3, okay? Right here. I put in a 1 and I get out a 3. All right, so next I'm going to have to find f of 2. All right, I'm getting this formula from right here. Whatever number is in the parentheses is what you plug in for the letter N. All you do is simplify. You say 2 minus 1 is 1. Do you see what I'm doing? I'm just simplifying and bringing my terms down. Well, now you have to be able to know the term before to answer this. So look right here, f of 1. I'm going to have to think, oh my gosh, what is the term? Going back up here and I'm saying f of 1 is 3. And I'm just adding on that 1. I'm getting 4. So that means when I plug in a 2, I'm getting out a 4. Okay? It just keeps going and going and going. We are going to go over topic 1 together as a class on Monday. So don't forget your quiz is open today. It is due Sunday at 6. Your more practice is not 6. I'm so sorry. It is due Sunday at 3. Your more practice is due Sunday at 3. And then you do have an assignment due today at 3. Your geometric SAS 3, I believe. SAS 3. And guys, listen, you have to do this stuff. This is how I keep your attendance. So if you don't complete your work on the due date and by the given time, then I have to mark you absent for my class. And we all know that a lot of absences can lead up to things that we don't want to do, like ISS or ALC. So we need to make sure we are doing our work. Another thing, on Agile Mind, I can see how long you've been on there. Okay? So like yesterday, I saw some people were literally on there for 6 minutes. 6 minutes. There is no way under the sun that you could have completed those slides in 6 minutes. Shout out to all my people. Had a lot of people who spent anywhere from 45 minutes to an hour and 30 minutes. Shout out to y'all guys. I'm very proud of y'all. I can tell who's really working and who's not really working. So just remember, guys, we have to do this stuff. I know it's not ideal, but I'm really trying my hardest to make it manageable for you, okay? So if you have questions today, let me know. I'm going to upload this video and might do a Teams call this afternoon, so be on the lookout for that. Have a good day.